Okay, today's lesson is a little bit of a departure from what we've been talking about. It's just kind of stuck in there in the middle of chapter 1, but it's fun to talk about, so we're going to do it. And it is about precision and measurement. So, for example, okay, this is a picture of Noah's watch. This is a picture of Mia's watch. And so it says, you ask your friends for the time. Noah says, it's about 2:30, right? Looking at his watch, it's about 2:30. Mia says it's 2:28 and 19 seconds. Okay, Mia's watch gives a more precise measurement for the time. Okay, her watch is more precise than Noah's. And precision is the level of detail that an instrument can measure, right? Noah's watch just couldn't measure the seconds, right? It really couldn't even measure the minutes. So Mia's watch was much more precise because her watch can give a level of detail that Noah's watch cannot. Okay, so what we're going to do is we're going to compare a few measurements and see if we can figure out which one is more precise. Okay, so if you said it's 7 centimeters and I said, well, it's 7.3. Mine is more precise, right? I measured it to the 10th place. So that's more precise. Okay, if you said something was 5 yards and I said, well, it's also 16 feet. Which one is more precise? 16 feet is more precise. And actually, I'm going to label this because it's a smaller unit, right? Feet is a smaller unit than yards. So automatically, if we're measuring it to the foot, not the yard, that's more precise. Okay, and then which one of these would be more precise? If I said you need 1 pint for the recipe, and someone else said, well, you need 16 ounces. Which one is more precise? 16 ounces, because the measurement of ounce is smaller than pint. Let's look at D. You can pick 21.13 ounces or 21.4. Which one would be more precise? 21.13, because this one was measured to the hundredths place. This one was only measured to the tenths. Letter E, which one? 14 millimeters is going to be more precise because it's measured to a smaller unit. Okay, what about 14 and a half inches or 2 5/8 of an inch? And you might be thinking, wait, they're both inches and they're both fractions, but this was measured to a half an inch. This was measured to an eighth. So this is more precise. Okay, what about 2.5 hours or 90 minutes? 90 minutes is more precise because minutes is a smaller unit than hours. So if it's a smaller unit or it's measured to a like a smaller decimal point, then then that's going to make it more precise. Okay, so now what we're going to talk about are significant digits. Okay, so I'm going to show you this example in my book. Let me see if I can get this going here. Okay. Okay, so it says, to the nearest centimeter, the diameter of a U.S. quarter is 2 centimeters. Right? So if we're looking at this quarter, it's 2 centimeters to the nearest centimeter. Measured to the nearest millimeter, the diameter of the quarter is 24 millimeters, right? 10, 24. The measurement 24 millimeters is more precise because it is given using a smaller unit of length. In the 2 coin measurements, notice that the numerical value 24 has more digits than the value 2. Right? 2 centimeters versus 24. Okay? you can use the number of significant digits to describe the precision of a measurement. Significant digits are the digits in a measurement that carry meaning, contributing to the precision of the measurement. So that's a lot. So let me write it out here. Significant digits are the digits in a measurement. Oh, it would help if you could see that. There we go. The digits in a measurement that carry meaning, contributing to the precision of the measurements. Okay, so if you need to pause it for a second and get that definition down, that's absolutely fine. Okay, so let's talk about what digits are significant. Okay, so if I gave you the example of 281.39, okay, 281.39. The significant digits in that example are 2, 8, 1, 3, and 9. Okay, there are 5 significant digits, all non-zeros, right? 1, 2, 3, 4, 5. There are 5 non-zero numbers. Okay, the next rule is that zeros to the right of both the last non-zero and the decimal point. Okay, so 0.0070. So if we're trying to figure out, okay, well, what digits here are significant? Okay, so I know that it's anything that's a non-zero, so that's 7. But then that leaves me with all of these zeros, right? And I'm like, well, how do I know which zeros are significant? It has to be to the right of the decimal and to the right of the last non-zero. So these two, this one is not even to the right of the decimal. These two are to the right of the decimal point, but are they after a non-zero number? No. This is the only zero that's after a non-zero number. So those are the only 2 significant digits. So there would be 2. Okay, and then the last rule is 500, or let me give you the example, 500.7. Okay, so this says zeros between significant digits. So if I'm going through and I'm looking at, okay, well, what's significant? 5 is and 7 is because they're non-zero. Okay, and then these 2 zeros are because they're in between significant digits. So this number has 4 significant digits. So your brain might be spinning just a little bit. Okay, and then let's look at this last thing, or at the top of your next page. It says zeros at the end of a whole number are usually assumed to be non-significant. For example, 220 centimeters has 2 significant digits, right? These are non-zero. And then if you're like, well, is a 0 significant? It's only if it comes to the right of a decimal and after a non-zero. Is this to the right of a decimal point? No. So those 2 aren't significant. Okay, but 202, non-zero, non-zero, in between non-zero, has 3. So let's look at some examples, and we are going to determine the number of significant digits. Okay, so I like to start off by going through and seeing which ones are non-zeros. Bam, bam, bam. Okay, so now I'm left with zeros, right? And that's what I'm trying to, that's the hard part, is figuring out if zeros are significant or not. So these zeros, are they in between significant digits? Yes. So that means all 5 of these are significant digits. Okay, so let's look at letter B. I automatically know that those two are significant because they're not zero. They're non-zero numbers. So now, to figure out about the zeros, I have to see, well, are they in between significant digits? No. Well, are they to the right of a decimal? Yes. Are they to the right of a non-zero? Yes. So this one has 4 significant digits. Okay, and then letter C, this is a non-zero, so automatically that's a significant digit. Are these zeros in between significant digits? No. Are they to the right of a decimal? No. So the only significant digit is 1. Okay, so let's look at some rules when you're doing different operations. Okay, what you have to do with significant digits. So if you are adding or subtracting, it says round the sum or difference to the same place as the last digit of the least precise measurement. Okay, so for example, if I gave you 2.34 and then 7.3, okay, so let's go ahead and add this together. We're adding these, okay? Then this would be 4, 6, and 9. Okay, so this number right here is rounded to the hundredths. This is rounded to the tenths. So if I am adding or subtracting, I have to round the sum or difference to the same place as the last digit of the least precise measurement. So because the least precise measurement is tenths, I'm going to round my answer to tenths. So my final answer is 9.6, right? Because tenths is less precise, my answer. I can't say with assurance that this is 9.64, because what if this was an 8, but they just didn't measure that, right? If they're only measuring it to the tenths place, right? So the only way that I can be accurate is to round it to the least precise measurement. Okay, let's talk about multiplication and division. The product or quotient must have the same number of significant digits as the, move that up. The product or quotient must have the same number of significant digits as the least precise measurement. Okay, so let's say we were doing 40 times 31. Okay, so I'm going to go ahead and just do my normal, right? 1 times 0 is, sorry, I was reading something. 1 times 0 is 0. 1 times 4 is 4. And then I'm going to put a 0 to show I was here. 3 times 0 is 0. 3 times 4 is 12, right? So what I get is 1,240. Okay, but now I have to look at the significant digits. How many significant digits does 40 have? Well, I know that 4 is significant. This is not, because it's not in between and it's not after a decimal and after a non-zero. So this is 1 significant digit. Okay, this one is 2 significant digits. But I have to round it to the least number of significant digits. So I can only have 1 significant digit. So if I was going to write this with 1 significant digit, I could only round it to 1,000. So we're going to do 4 examples. It says, perform the indicated operation and write the answer with the correct number of significant digits. Okay, so the first one that I have is 45.1 centimeters plus 19.45 centimeters. So what I'm going to do is I'm going to add those like normal. 45.1, 19.45. Okay, and I'm adding. So 5, 5, bring down my decimal, 14, 6. Okay, but remember what it said on our previous page, that we're going to round to the same place as the last digit of the least precise measurement. So my least precise measurement is this one, and this is the tenths place. So I'm going to round my answer to the tenths place. So instead of 64.55, it's 64.6 centimeters, right? And again, you have to think about it. It's like if I was combining my measurement, if this was what I measured and this is what you measured, we can't say with assurance that it is actually 64.55 centimeters because I didn't measure what the hundredths place is. You did, right? You measured the hundredths, but I did not. So we can't include and pretend like I measured the hundredths place. Okay, let's go ahead and do C because that deals with adding and subtracting again. So 27.23 minus 12.7. Okay, so 3 minus 0 is 3. Then I'm going to make this a 12 and this is 6. 12 minus 7 is 5. Put my decimal. 6 minus 2 is 4. 2 minus 1 is 1. So it's 14.53. Okay, what's my least precise measurement? It's this one, right? This is only rounded, or only measured, excuse me, to the tenths place. So therefore, my answer can only be measured to the tenths place. So when I do that, I am going to get 14.5 meters. So now let's come up here and look at B. So this is multiplication. So I have 2.15 feet times 6.4 feet. So 4 times 5 is 20. 4 times 1 is 4, plus 2 is 6. 4 times 2 is 8. I put a 0. 6 times 5 is 30. 6 times 1 is 6, plus 3 is 9. 6 times 2 is 12. So 0, 6, 17, 3, 1. Okay, and when I'm looking at it, my decimal should come 1, 2, 3. 1, 2, 3. Okay, but now I have to look at, remember the rule is the least number of significant digits. So this has 3 significant digits. 1, 2, 3. This has 2 significant digits. So my answer can only have 2 significant digits. So I'm going to have to round it to this whole number right here. So is it going to be closer to 13 or 14? 14 feet. Okay, and then our last one, we have 45.16 being divided by 4.25. Okay, I'm going to go ahead and move my decimal 2 over and move this one 2 over, or over 2. So 425 can go into 451 once. 1 times 425 is 425. I'm going to subtract. When I subtract that out, 450 minus 425 is 25, but it's 51, so that's 26. And then I bring down a 0. Can 425 go into 260? 0 times. 0 times 425 is 0. 2, 6, 0, 0. Okay, how many times do we think that 425 can go into 2600? Take a guess. What do y'all think? Okay, I'm going to guess 6 times. So I'm going to come over here and do 425 times 6. 5 times 6 is 30. 6 times 2 is 12, plus 3 is 15. 6 times 4 is 24, plus 1 is 25. So that was a pretty good guess. So 6 times 425, I already did it, is 2550. Okay, so when I subtract, 2600 minus 2550 is going to be 50. Okay, I'm going to stop here for a second. Well, I can keep going. Let me do one more. If I pull down a 0, how many times can 425 go into 500? Once. Okay, here's why I stopped there. Because how many significant digits is this? 4 significant digits. 4.25 is 3 significant digits. Okay, so I have to have an answer that has 3 significant digits. Significant, significant. Is this closer to 6 or to 7? Because this is a 1, I know it's closer to 6. So my answer is 10.6 yards.